Hello everyone, welcome to another Algebra and Trigonometry with Professor V. So this is going to be our last video of simplifying expressions with variables. So let's go ahead and jump into it. By now I would encourage y'all to try, pausing the video and trying to solve a little bit of these, although with the distribution property, these are a little trickier, but it's okay. Let's go ahead and work these out and see what we can learn. So the first one we're starting off with looks like 18y minus 2 times the quantity 1 plus 7y. Okay. So I go in the parentheses, right? Hopefully by now order of operations is becoming second nature, right? I cannot combine these, right? I have a 1 plus 7y, so they're not like terms. But I have a subtraction and then I have a multiply, right? So according to PEMDAS, I got to do the multiply first. So it is distribution property, right? Kind of like we saw in the last video. Now here's the tricky one. I want to look at this as negative 2, okay? So this is negative 2 times 1 minus 2, okay? And then negative 2 times positive 7y, so that's going to be negative 14y. Okay, so it is a minus 2, but what is a minus 2, right? It's adding negative 2. So we got to start getting used to this idea that the sign in front, right, tells me if the number's negative or positive. So anyway, well, this one's pretty simple, right? I see an 18y, I see the minus 14y. They're like terms, right? So 18 minus 14 will be 4y. And then we didn't do anything with the minus 2, so minus 2. And that'll be our answer for number 48. And that is a little bit tricky, right? To think of this distribution as negative, but I promise you guys, if you could put this in your head, oh, life will be so much more glorious when you're working on math. It'll be that much more simpler. Which is what we're here for, right? We all want to be encouraged to think and do great things. But anyway, so now we have 4/9 squared times 27x, okay? So this one's a fun one. So 4/9 squared, right, is going to be 4/9 times 4/9. Or if you know your polynomial rules, right, you could just square the top and square the bottom, which is pretty much 4 times 4, 9 times 9, right? We don't have any factors here to cancel out, so we're stuck. So we end up with 16, and let me see if I could actually just kind of do this underneath. So we have 16 over 81, because that's 4 times 4, 16, 9 times 9, 81. Now we have 27x. And the easiest way to go about this one, so this one I'm not going to multiply, I will factor out, right? I already know 27 and 81 are factors of 9, right? So I kind of showed you the divisibility test with 3's. Well, if you add the numbers, 2 plus 7, 9, 8 plus 1, 9, they're both divisible by 9. So there's some cool numerology that happens there. But anyway, so how many 9's will fit into 27? 3 of them, right? So that'll be 3x on this side, and then how many 9's fit into 81? 9 of them. So now we can multiply like normal. I don't know if to pull this to the left or to the right. Ugh, so just doesn't seem like there's enough room for all of these. But anyway. Okay. And I feel like I didn't go far enough, right? There's another factor I could do here. What could I have done different other than 9? Could I have maybe used 18? I don't know. But anyway, so we also have another factor of 3, right? So how many 3's fit into 3? 1. How many 3's fit into 9? 3. So when all the smoke clears, Looks like we have 16x over 3. So 16 times x, I guess I'll just put it here. These do not simplify, right? 3 will not fit into 16. The only other way you could write this is 16 over 3, and then have the x on the side. Okay, so these are our answers. Both are correct, they're just in different forms, okay? Alright. So what's the next one? I don't know if I'll be able to fit that one here, but I'll keep carrying on down here. Especially 51. 51's kind of the one where I'm like, I'm running out of room. So I hope this one wasn't too confusing. This does, as I'm working on it, I feel like I might get some gas about it. But anyway, so the next one, 50, is going to be 8 times the quantity, 3 minus m, plus 1 times negative 8. Okay? So I have a couple multipliers to handle, right? I have this, I go in the parentheses, I cannot combine like terms, right? The 3 doesn't have an m. So I start doing distribution. I start doing 8 times 3, 24, right? 8 times negative m, negative 8m. And then here, well, this is positive 1 times negative 8, right? This is also multiply, so might as well handle this right away. So that's going to be, excuse me, minus 8. You might say, where did I get the minus 8 from? Because it's positive times a negative, right? We could leave this as plus negative 8, but it's easier to just write it as a minus 8 right away, people. So that's where this is coming from. Please try not to get too confused on this, but I know. It's tricky to see the plus in front of the 1 and think of it as positive, but just, open your brains a little bit, expand your thinking. It's not too far of a stretch, okay? But anyway. So 24 minus 8 is going to be 16, right? So now we have 16 minus 8m. Now this could be negative 8m plus 16, right? So we could do the whole keep change business. So you keep 16, change the sign to plus, right? The opposite, change the positive 8m to negative 8m. And then we would use the commutative property and flip these, right? So that would be negative 8m plus 16. So that would be the true answer, Not that 16 minus 8m is wrong, but any math teacher that I've ever had as far as calculus and engineering goes will always write it like this. So, and they do it without even showing it, right? They just... They've been practicing math for so long that they're the master of it. Okay, and I might be able to squeeze 52 here or under here, so we'll see how this works, but 51 is going to take some space, so let's see. So we have 9x plus 4x times the quantity, 2 plus 3, minus 4 times the quantity, 2x plus 3x. So this one's very interesting. This one's starting to get super fun. So we do have to go into the parentheses. Okay, so we have 9x plus 4x times what? Times 5, right? In this parentheses, these are like terms this time, right? So plus 5. And then here we have minus 4. And then in this parentheses, we also have like terms. They just happen to be 5x. Okay. So now we have 9x. So we can multiply these, right? So plus 20x. 5 times 4, 20. Just carry along the x. Minus 4 times 5x. You might say, why are you not looking at this as negative? Well, it still is, right? Negative 4 times positive 5 will give you negative. So, when do we see this subtraction as subtraction or the negative? I guess it doesn't matter as long as you understand it's a minus. So anyway, so 4 times 5 will also be 20x. Now for these we would normally go left to right, right? But I hope you guys can see these 20s would cancel, right? We're left with 9x. And if you don't believe me, we'll go left to right. we'll say 9 plus 20x, right? Oops, 29x. And then you're going to take away the 20 that you just added to that, so you're back at 9x, right? So hopefully we saw that these would just cancel each other out, right? Alright, and that's how we go about 51. Now 52, I think I'm going to squeeze in this little box here. This one doesn't look too bad. So we have 5 squared minus 4 times 3x. Okay, so now we have 25 minus 4 times 3x. So we have 25 minus 12x, right? And hopefully you guys are savvy that this will be negative 12x plus that, but plus 25, but let's just keep change. 25 plus negative 12x. And then it'll be negative 12x plus 25. Oops, I forgot the x. And that'll be the true answer that probably most mathematicians are doing it in this way, or, you know, at least your teacher's definitely, you know, going to show you it in this way. I guess I could cover the PEMDAS up a little bit. All right, there we go. So, you know, what did we learn in this section, right? We learned about like terms, right? We can only add and subtract things if they had the same variable and the same power. Now, I don't remember if we did an x with an x squared or not, but, you know, you cannot combine x with x squared, right? If x is equal to 4, right, we got to realize that what we're checking we're checking, right? Is x equal to x squared? Well, no, right? 4 is not equal to 16, right? This is not equal. So they're not like terms, right? 16 somethings is not 4 somethings, right? And it breaks the multiplication, right? Because one would be 4 plus 4 plus 4, however many times you're doing it. The other one would be 16 plus 16, right? So if you have some kind of 4 plus 16, right? Well, that's not repeated addition, right? That's not multiplication. So that's probably a lot to go on, but you know, just know that you cannot combine things unless they have the same variable and the same power, or if they even lack the variable, right? If they're just good old-fashioned whole numbers like 2 plus 3. We also kind of covered the distribution property, right? How do we handle quantities when they're multiplied by a constant, right? Or maybe even a constant with a variable. So we do what's called the distribution property and multiply by every term inside of the parentheses. We also learned that terms are separated by plus and minus, right? So 4y minus 2 is a 2-term problem, right? Something like 9x is a single term. So these are cool things to just remember. Order of operations is used probably exhaustively throughout algebra, right? This is about the 3rd section we're on in this video series, and so far it's been nothing but order of operations, right? A couple of things. And then the rewriting of a problem, right? So do be careful, right? You can do all this math and get an answer, but there's always ways to rewrite things in math, and that's probably the tricky part, right? Is remembering these silly little rules that they teach us that we think we'll never use again, right? But we do. So yeah, I hope you guys got some value out of these videos. Please like and subscribe so that way you're following along and keeping up with all the new uploads. Comment down below if something's a little bit fuzzy. You know, we could go through the book and check it out. Other than that, I hope you guys have a great day, and I will see you in the next video.